Nomenclature is a set of rules that we use for getting the names and formulas of compounds. We're going to be starting off with simple binary ionic compounds. Let's first off define what an ionic compound is. An ionic compound is made up of two or more ions, and an ion is an atom or group of atoms that has a charge. These two or more ions combine to make a compound. A compound, however, does not have a charge. It's neutral, or we can also say that it has a zero charge. Ionic compounds are typically going to be made up of a metal and a nonmetal, or it could be made up of polyatomic ions with metals or nonmetals, or simply just polyatomic ions. Ionic compounds typically start off with the positive part, which is called the cation. I like to remember that the cation is the positive ion because there's a T right in the middle, and that looks like a positive sign. Or you can remember it by knowing that a cat has paws, and that a cation should be positive. The second part of an ionic compound is the negative part, and that is called an anion. The way I like to remember anion is that it is a negative ion. Our rules for naming ionic compounds states that we keep the name of the cation. Now, the anion will depend on what it's made of. If it's a nonmetal, we're going to keep the root and change the ending to "ide," but if it's a polyatomic ion, we're going to keep the polyatomic ion's name. Let's try out a few examples. First one is NaCl. A huge hint here is every time you see a new capital letter, that's a new element. So that's going to help us determine whether we have elements or polyatomic ions. Here, since there are only two capital letters, we only have two elements. Most likely, this ionic compound is made up of a metal and a nonmetal. Na is the metal sodium. According to our rules, we're just going to keep its name. Cl is the nonmetal chlorine. But according to rule number 2, we need to change the ending to "ide." Typically, we're only going to chop off the last syllable, in this case "ein," and change it to "ide." So the name for NaCl should be sodium chloride. Now, NaClO3. Here we have 3 capital letters. So one of these has to be a polyatomic ion. From the previous example, we know that Na is an element, but you don't know whether NaCl is a polyatomic ion. So you can look through the list, but since that was actually the compound before, we know that it's not. The polyatomic ion is ClO3. Every time you have a polyatomic ion, I suggest you put it in parentheses to remind yourself that that is the polyatomic ion. Na is called sodium, and ClO3 is the polyatomic ion chlorate. According to our rules, we keep the name of we keep the name of the cation, and we're going to keep the name of the polyatomic ion, so sodium chlorate is the name for NaClO3. Let's move on to our last example. NH4Cl. Again, there are too many elements here. One of these has to be a polyatomic ion. NH4 is the polyatomic ion here, and NH4 is the cation. It's actually in your first column of your polyatomic ion chart. NH4 is called ammonium. Cl is chlorine, but since Cl is a nonmetal, we need to scratch out the ending and change it to "ide." So NH4Cl is called ammonium. chloride. Now let's go over the rules for getting formulas. The first step is to find the symbols or the formulas for the cation and the anion. The second step is to find the ratio of cations and anions in order to make a compound. And remember that a compound is neutral and therefore is going to have a total overall charge of 0. Let's try out example number 1, lithium sulfide. Lithium is the metal with the symbol Li, and that's what we have to do first. Get the symbols and the charge. So lithium is Li, and it has the charge of +1. Sulfide, it ends in "ide", so we're most likely going to find this on the periodic table within our nonmetals. So look for a nonmetal that begins with sulf, and that should be sulfur, S. Its charge is -2. Remember that this is supposed to be a compound and have the overall charge of 0. So let's look at our charges right now. A +1 and a -2. These guys are not going to cancel out to give us 0. So we need to find the ratio using subscripts so that our overall charge is 0. What we're going to actually do is find the least common multiple between 1 and 2. We're going to do this by putting houses above our charges and the numbers above the houses is going to be the least common multiple of those two. They should cancel out to give us 0. The least common multiple between 1 and 2 is actually 2. In order to get a +2 above the house for lithium, we're going to need to increase the number of lithiums. We're going to need 2 lithiums so that when we multiply that subscript 2 by +1, we're going to get a total overall charge of +2. We need to cancel out that +2, the -2. So we need to multiply a subscript by -2 in order to get -2 up top. The subscript for S will have to be 1. 1 times -2 is going to give us -2. +2 minus 2 is that's going to equal 0. To get the correct formula, though, we cannot show charges. It's going to be Li2S. We actually do not show 1s within our formulas, so that would be incorrect up there. Li2S is the correct formula for lithium sulfide. Let's look at calcium carbonate. Calcium is also a metal, it's Ca. Its charge is +2. Carbonate will be found on the polyatomic ion chart. Carbonate is CO3. Its charge, -2. Remember I told you guys you should put polyatomic ions in parentheses just so we know what the actual polyatomic ion is. Now, right here, +2 and -2 will cancel out to give us 0. So we don't need to find their least common multiple. When the charges cancel out right off the bat, all we have to do is rewrite the formula. You can write it with the parentheses or without. Either way would be correct in this case since there's only one carbonate. Let's look at barium phosphide. Barium is also a metal, Ba. Its charge is +2. Phosphide is a nonmetal with the symbol of P. Its charge is -3. Those charges are not going to cancel out right off the bat, so we need to find their least common multiple. Those are going to cancel out to give us 0. The least common multiple between 2 and 3 is actually 6. So we need a +6 above the house for barium. That means that we're going to need 3 bariums to multiply by the charge of +2 to give us an overall charge of +6. For phosphorus, we're going to need 2 to multiply by -3 to give us a -6. The +6 and -6 will cancel out to give us 0. Now we need to rewrite the formula without the charges. It should be Ba3P2. And I do want you guys to notice that the subscripts, like a submarine or the subway, is underneath these symbols. Really, it's kind of like on the line that we draw the symbols on. Okay, be careful with those, don't draw them too large. Now let's get the formula for aluminum iodate. Aluminum is a metal with the symbol Al. Its charge is positive 3. Iodate is a polyatomic ion, IO3, with a charge of negative 1. Remember, I asked you guys to put polyatomic ions in parentheses. Plus 3 and negative 1 are not going to cancel out to give us 0, so we need to find their least common multiple. In this case, the least common multiple is 3. In order to have a total overall charge of positive 3 for aluminum, we actually don't need to multiply it by anything. But for iodate, to get a total overall charge of negative 3, we are going to need 3 iodates. Now the 3 has to be outside of the parentheses. So now we're going to have an overall charge of negative 3 for iodate. They cancel out. So when we rewrite the formula, it's going to be AlIO3 in parentheses with a 3 on the outside. That is the correct formula for aluminum iodate. Now let's look at ammonium sulfate. Ammonium is the polyatomic ion NH4. It has a positive 1 charge. It's a polyatomic ion, so I want you guys to put it in parentheses. Sulfate, also a polyatomic ion, it's SO4 with a negative 2 charge. We're going to put that polyatomic ion in parentheses. These charges are not going to cancel out, so we need to find their least common multiple. In this case, it's going to be 2. In order to get a positive 2 for ammonium, we are going to need 2 ammoniums. To get a negative 2 for sulfate, we're only going to need 1, so we don't need to add a subscript. Let's rewrite the formula. It should be NH4 in parentheses with the 2 on the outside, and then SO4. That is one correct formula. Or you can write both polyatomic ions in parentheses.